The ABC Corporation is opening new retail sales outlets, and they want to staff these stores with employees most likely to be successful at selling the products. To meet this goal, ABC decides to study the sales staff at existing stores to determine if intelligence and extroversion, i.e., whether someone has a friendly and outgoing personality, predicts sales performance of current employees. The logic is that if intelligence and extroversion predicts performance, then a good strategy for new stores is to hire intelligent extroverts for the sales positions. To conduct the study, all current retail sales employees at existing stores take psychological tests designed to measure intelligence and extroversion. Also, past sales performance data is checked for each employee. In the end, there are 3 scores for each salesperson. Number 1, an IQ score on a scale of 50 is low intelligence to 150 is high intelligence. 2, an extroversion score on a scale of 15 low extroversion to 30 high extroversion. And 3, a sales performance expressed as the average dollar amount sold per week. In these types of studies, the variables used to forecast intelligence and extroversion are called predictors, and the variable being forecast, in this case sales performance, is called the criterion. The predictor and criterion data are what we see before us for 20 current sales employees of the ABC Corporation. What can you tell the executives about their salespeople from this data? So our criterion, or our output, is our Y, the dollar sales per week. Everything else is our input, or our X. Odds are the salesperson number doesn't have anything to do with the sales per week, but let's check it anyway. We have the data, we might as well run the regression. So my Y is my sales per week. My X is everything else. I turn off constant to 0, I left labels checked, and we run the first regression. Now we end up with an R squared of 41, which is horrible. Our intercept is above 0.05, and our salesperson number is 0.56. So clearly, salesperson number isn't really related. So let's go back to our sheet, run our regression again, and let's eliminate salesperson number out of it and just look at intelligence and extroversion. Now with the second regression, our R squared is still 40, which is not great. The p-value for our intercept is 0.14, which is above 0.05, and our intelligence p-value is also 0.09. But let's just get rid of the highest one and see where we're at. So let's get rid of the intercept, which means constant is 0. And what are we looking at here? We have 2 p-values well within the range. The intelligence p-value is 0.006. The extroversion p-value is, in case you don't know, this is scientific notation. It's basically you have to move the decimal point over 6 spaces to the left. So it's 0.505, very low number. So what we're looking at is an equation where sales per week is equal to 10.5 times the IQ plus 80 times the extroversion quotient. So let's call that EQ. So if I wanted to predict sales per week and I had IQ and EQ, then I would be looking at sales per week are equal to IQ times 10.59 plus EQ times 80.26. So somebody with an IQ of 100 and an EQ of 23 would probably sell $2,900 worth of product per week.